Hi everyone, in this lecture we are going to solve a problem in chemical engineering thermodynamics. The problem statements are given here. Assume Raoult's law to be valid for the system benzene 1, ethyl benzene 2, and the vapor pressure are given by Antoine equation where P is in kilopascal, T is in Kelvin. Construct the following: the PXY diagram at 373 Kelvin, the DXY diagram at 101.3 kilopascal. We are going to solve the problem in two portions. In first portion, we are going to construct PXY diagram using Excel. Step 1. Determine P1s and P2s using Antoine equation given in the problem at 373 Kelvin. These are the Antoine equation given in the problem. Ln P1 is equal to 13.8858 minus 2788.51 divided by T minus 52.41. Equal to 13.8858 minus opening bracket 2788.51 divided by T 73 Kelvin minus 52.41 close the bracket, again close the bracket. Ln P2s equal to 14.0045 minus 3279.47 divided by T minus 60. Minus 3279.47 divided by T minus 60.00. Once after determining ln P1s and P2s, let us determine P1s and P2s. P1 is nothing but exponential of ln P1s. P2 is nothing but exponential of ln P2s. Step number 2. Assume x1 values between 0 to 1 as mole fraction of component varies from 0 to 1 and calculate x2 using x2 equal to 1 minus x1 since given system is binary mixture. x1, x2. I am going to assume x1 value from 0 to 1, 0.3. Extend the logic to the now x2 equal to 1 minus of x1. Copy the formula to the entire column. In step number 3, determine P total pressure for the various values of x and PS using Raoult's law. Total pressure equal to P1 minus P2, and according to Raoult's law, P1 equal to x1 into P1s and P2 equal to x2 into P2s. Substituting these terms in the above equation, we will get total pressure equal to x1 into P1s plus x2 into P2s. I am going to use this formula to determine total pressure for the various mole fraction. Total pressure equal to x1 multiplied by P1s plus x2 into P2s. I am going to make a small adjustment in the formula. I am going to put dollar symbol in front of B and after the B in order to lock the cell for the entire columns. And I am going to copy the formula to the entire column. If you look at the formula, here A9 and B9 and second cell A10 and B10, but the B5 and B6 cells are fixed here. That's why I put the dollar symbol to lock the cell of P1s and P2s. Since P1s and P2s doesn't change with mole fraction, it is constant for the given temperature. In step number 4, determine Y1 and Y2 by comparing Dalton's law and Raoult's law. This stands for the Dalton's law, this stands for the Raoult's law. From that, Y1 will be equal to the P1s x1 divided by P. From that, Y2 can be determined by the formula, that is 1 minus Y1, since given mixture is binary mixture. Y1 stands for the mole fraction of the component in the gas phase or vapor phase. Y1, Y2. P1s into x1 divided by total pressure. Similarly, I am going to lock the cell B5 by putting the dollar symbol in front of B and after the B. From that, Y2 can be calculated by 1 minus Y1. Copy the formula for entire column. We successfully calculated or generated the PXY data for the given benzene ethyl benzene system. Now let us construct PXY diagram at 373 Kelvin. Scatter, select data, add series name P X diagram, X values, entire X1 column, Y values, P data. Thus we have plotted the PX diagram. Add series name P Y diagram, X values, entire column of Y1, entire column of X values, entire column of Y1, Y values, entire column of P values. Thus, we have successfully constructed the PXY diagram for the given benzene ethyl benzene system. The second question, let us construct PXY diagram at 101.3 kilopascal. In order to construct PXY diagram, step number 1, assume x1 values between 0 to 1 as mole fraction component varies from 0 to 1 and calculate corresponding x2 using x2 equal to 1 minus x1 since given mixture is binary mixture. Let us assume x1 from 0 to 1 and calculate x2. We have completed successfully step number 1. In step number 2, assume T equal to 300 Kelvin and determine P1s and P2s using Antoine equation given in the problem. Assume T as 300 Kelvin for the entire mole fraction. And determine P1s and P2s. P1s, P2s. P1s equal to exponential of opening bracket 13.8858 minus opening bracket 2788.51 divided by T minus 52.41 close the bracket, close the bracket, close the bracket. Drag the entire formula to the drag the formula to the entire column. P2s equal to exponential of 14.0045 minus 3279.47 divided by T minus 60. Close the bracket, close the bracket, again close the bracket. We have successfully completed step number 2. In step number 3, use goal stick to find the true temperature corresponding to the assumed mole fraction. For the above, use the equation P equal to x1 P1s plus x2 into P2s. I am going to calculate P for the temperature what I assumed here. P equal to mole fraction of component number 1 into vapor pressure plus mole fraction of component number 2 into vapor pressure of component number 2. If you look at this column, the P which I have calculated according to what I assume as it is 300 Kelvin, but in the problem statement P is given as 101.3 kilopascal. I'm going to use goal stick to reassume or recalculate temperature for the pressure of 101.3 kilopascal. You have to use goal stick, click on data, under what if analysis, goal stick, set the value F3 to the value of 101.3 kilopascal by changing temperature value. Now we have calculated the corresponding temperature for this mole fraction. Similarly, I am going to do the same thing for entire column. What if goal stick to the value of 101.3 kilopascal by changing cell of T. Yeah, now we successfully generated XTP data. The problem, pressure is given as 101.3, approximately in all the P column we are getting 101.3 kilopascal. Step number 4, determine Y1 and Y2 by comparing Dalton's law and Raoult's law. Y1 equal to P minus X1 divided by P, Y2 equal to 1 minus Y1. Y1, Y2. Y1 equal to X1 into P on S divided by total pressure. That will be the formula for the entire column. That will be the formula for the entire column. Y2 will be 1 minus half Y1. Y2 will be 1 minus half Y1. Copy the formula to the entire column. Now we have successfully generated TXY data. Let us construct the TXY diagram. Y1 is our temperature data. Add T Y diagram. X values Y values. Now we have successfully constructed TXY diagram. Thank you for watching the video. Thank you.